So far we have talked about central angles and inscribed angles. Now we're going to look at angles that are formed by intersecting chords, secants, and tangents. Intersections can either happen inside the circle, on the circle, or outside the circle. Let's start by looking at intersections in the circle. If you have two secants, such as line AC and line BD, or two chords, such as segment AC and segment BD, that intersect inside the circle, then the measure of the angle that you're looking for is going to be equal to half the sum of the measures of the intercepted arc. So if you're looking at angle 1 intercepts arc AD. Here's angle 1, the arc that's in between the endpoints of the angle is AD. But because of vertical angles, this angle that doesn't have a name is going to be congruent to angle 1, and its intercepted arc is BC. So to find the measure of angle 1, you are going to add the measures of arc AD and BC, and then divide by 2. If you want to find the measure of angle 2, angle 2 is right here, and it intercepts arc AB. Its vertical angle intercepts arc CD. So if you want to find the measure of angle 2, you would add the measure of arc AB and the measure of arc CD and then divide by 2. Keep in mind that angle 1 and angle 2 form a linear pair, and they should be supplementary. So if you have the measure of angle 1, you should be able to find the measure of angle 2 and vice versa. So let's look at a few examples to practice. All right, in our first example, we are looking for the measure of angle AED. So AED, start at A, go directly to E, and then go to D. Its intercepted arc is AD, which is 45 degrees. So to find the measure of angle AED, we're going to take its intercepted arc, which is 45 degrees. We're going to add it to the intercepted arc of its vertical angle. So its vertical angle is right here. That's angle BEC. And angle BEC intercepts arc BC, which is 109, and then we're going to divide by 2. So we're going to do 45 plus 109 divided by 2, and you can do that all at once, or you can do it bit by bit. That's really up to you. That's 154 divided by 2, which is 77 degrees. In our next picture, we're looking for, and for some reason it kind of got cut off, but that should be an arc. We're looking for the measure of arc QT. So QT is this arc right here. We do know the measure of arc RS, which is the intercepted arc of the vertical angle. So if we're looking a little bit closer, QT is intercepted by angle QUT. And we don't know that angle, but we can find it because we do know that angle RUQ is 79 degrees and they're a linear pair. So I'm going to start by finding that angle. So to find that angle, since it's a linear pair, I'm going to do 180 minus 79, which is going to give us 101. And that's going to be not only for that angle, but for its vertical angle. So this one is kind of like working backwards. I'm just going to put an X on arc QT since that's what we're looking for. What we do know is if we add X in 95 and divide by 2, that should give us that 101 degree angle. So I'm going to set up an equation and I'm going to solve it. To solve it, the first thing I would do would be multiply both sides by 2. So that'll give me X plus 95 equals 101 times 2 is 202, and then we'll subtract 95 from both sides, which will give us 107 degrees. So the measure of arc QT is 107 degrees. So sometimes it's very straightforward, like the first problem where you're just adding the two arcs and dividing by 2. And other times you'll have one of the arcs and one of the angles, and you'll, set up your equation with x as that missing arc. You'll still add and divide by 2, but this time it'll equal the known angle. All right, so in our third example, we're looking for the measure of LK. So LK is right here. Its angle is LNK, which is 62. Its vertical angle is JNM, which would also be 62. And its intercepted arc is JM. So I'm going to put an X next to LK since that's what we're looking for. We do know if we add the two arcs, LK, which is X, and JM, which is 74, if we divide that by 2, that should give us the angle, which is 62. So very similar setup to the last one that we did. We're going to multiply both sides by 2, and on the left side, all that's going to do is get rid of the 2. You don't need to distribute the 2. You can, but then you would divide by 2, so it ends up working out the same. So that gives us x plus 74, and then 62 times 2 is what, 124. And then we're going to subtract 74 from both sides, and that is going to give us that the measure of LK is 50 degrees. Notice we're in degrees because we're talking about the degree measure of an arc, not the arc length. We don't have inches or feet or anything like that. Okay, so this time we have both arcs and we have the angle, but this time the angle is in terms of x. So here's what we know. We do know that if we add these two arcs, 75, right? Here's its angle, there's the vertical angle, and here's the other arc. So if we add 75 to 55 and divide by 2, it should give us the angle, which we know is 3x plus 23. So I'm going to multiply both sides by 2. On the left side, the 2's are going to cancel out, and we're going to have 75 plus 55. You could have also, which probably would have made more sense, just add 75 plus 55 and then divide by 2. I thought about it after the fact, so I'm just going to keep going with the way that I am already doing it. That's 130. And then we're going to distribute 2, which would be 6x plus 43. We're going to subtract 43 from 130, and I'm going to run out of room, which is 87. Oops, that should be 46, not 43. I'm sorry. 130 minus 46 is 84. Let me change those to 46. And then 84 equals 6x, so we're going to divide by 6, which is going to give us x equals 14. What I normally would have done, and I don't know why I really didn't think about it, but that's okay. I would have added 75 plus 55 and then divided by 2. So I would have just done 65 equals 3x plus 23, and then I would have solved that. For some reason, I went a long way around it, and that's okay. But I would have just done the math on that part right real quick instead of having to multiply both sides by 2. So again, when your chords or your secants intersect inside the circle, you're going to add the two intercepted arcs and divide by 2, and that will give you the measure of your angle. And just as a reminder, the difference between a chord and a secant is chords are segments. If you look at the picture on the left, LM and JK are segments. Those are chords. They stop on the circle, whereas secants go beyond. So it's like a chord, but it goes outside of the circle. So in the second picture on the right, those are secants. So chords on the left, secants on the right. If it goes through the circle, then it's going to be a secant. So now let's look at intersections on the circle. The good news is we've already done inscribed angles, and we know an inscribed angle has its vertex on the circle. So when the intersection is on the circle, it's very similar. The way you find the angle or the arc is the same way you find an inscribed angle. It's technically not inscribed because it's not two chords, but it still has the same relationship. So if you have secant and tangent lines that intersect at a point of tangency, then the measure of the angle formed is going to be equal to half the measure of the intercepted arc. So if we're looking at this picture, this line right here, I'll put it in yellow. This is a secant because it touches the circle once at point A. Point A is your point of tangency. And then you have the secant line, or I guess it's technically a ray, AB. All right, so if you have a secant that intersects a tangent at the point of tangency, it creates two angles, angle 1 and angle 2. So if I want to find angle 1 intercepts arc AB. So the measure of angle 1 is going to be half the measure of arc AB. Whereas if I'm looking at angle 2 intercepts arc ACB. And so the measure of angle 2 will be half the measure of arc ACB. So let's look at a few examples. All right, in the first one, we have the measure of angle DEG. So let's look at DEG. What arc does it intercept? Well, it intercepts starting at the vertex E, all the way through H, all the way through to point G is where it stops. And that arc EHG, has a measure of 308 degrees. So the measure of angle DEG will be half of 308. So I'm just going to do 308 divided by 2, which is equivalent to 154 degrees. Keep in mind that when you have that secant and that tangent intersect, it does create two angles. It creates the one that we just found, DEG, which is 154, and it also creates angle FEG. Those two angles are going to be supplementary because they form a linear pair, so don't forget that you can use that to maybe help you find something that you need as well. All right, so for our next example, we're looking for angle DBC, all right, DBC right here. That arc that it intercepts starts at B and then goes to D. And we do not have that arc measure. However, we do know that arc DEB is 192. So we can find the measure of arc BD by 360 minus 192, which is going to be 168. Those two arcs together make up the whole circle, so together it has to equal 360. So again, to find 168, I did 360 minus 192. And now that I know the measure of arc BD, I can take 168 and cut it in half, and that's going to give me the measure of angle DBC, which is 84 degrees. That's one way you could have found it. The other option would have been to say, okay, well, I know DEB is 192, and if I cut 192 in half, that gives me 96. And if this angle, ABD, is 96, then angle DBC has to be 180 minus 96, which is 84. So there are a couple different ways you could have done it. You could have found the angle and then used linear pair property, or you could have used the fact that you knew the two arcs were 360 degrees total and then cut it in half. Completely up to you and how you see it. All right, the next one, we are looking for the measure of arc XY. To find the measure of arc XY, it is that little tiny arc right there. So there are a couple different ways. It's kind of like the last one that we just did. There are two different ways to do it. What you do know is that angle YXW is 151, and YXW, this huge angle right here, intercepts arc XZY. So we could find that arc by doubling 151, because if the angle is half the arc, then the arc is double the angle, which if we do that, that's going to give us 302. So that means that whole thing in red is 302 degrees. So to find the little part in purple, I can do 360 minus 302, which is going to give us 58 degrees. The other option would have been to find angle VXY first, which to do that, since the two angles form a linear pair, you could have done 180 minus 151, which would have given you 29. And then to find the arc, double 29, and 29 times 2 is 58. All right, the last one of these, we don't even have any names for these. So we do have this 23-degree angle. And I'm just going to put a letter there just to make it a little bit easier. We'll call this AB. And we'll put a C on there. So angle CAB is 23 degrees. And it intercepts arc AB, which would be double that. So that would be 46 degrees. And what that means is this remaining arc, this 14x minus 22, all of this has to be 360 minus 46 degrees, which is 314. Oops. So what I can do is I can take my 14x minus 22 and set it equal to 314. So I'll start by adding 22, which gives me 14x equals 336. Divide both sides by 14, and that's going to give me 24 for x. The last type of intersection we're going to look at is when the intersection happens outside the circle. And there are 3 ways this can happen. And even though there's 3 different ways that it can happen, the formula for finding the measure of that angle outside the circle is still the same. So the first thing that can happen is you can have 2 secants. So if we're looking at the picture all the way to the left, AC is a secant and AE is a secant. So the measure of angle A, which is this actual angle right here, okay, it intercepts 2 arcs. Okay, so think about in between the sides of the angle, it intercepts arc BD and it intercepts arc CE. Okay, you're looking in between the angle. Don't look outside the angle. So to find the measure of angle A, you're going to take the measure of arc CE, the one on the outside, because it'll be the bigger one, and you're going to subtract the measure of arc BD and then divide by 2. It's a big arc minus small arc and then divide by 2. The next picture that we have is a secant and a tangent. So AB is a tangent because it touches just at point B. That's called the point of tangency. And then AD is a secant because it passes through the circle twice at C and at D. But just like the previous picture, when it does that, if you look in between the sides of the angle, it intercepts 2 arcs. BD is going to be your bigger one because it's on the outside, and then also BC. So if you're looking for the measure of angle A, you are going to take the measure of arc BD and subtract the measure of arc BC and then divide by 2. So half the difference of the 2 arcs. And finally, the last one we're looking at is 2 tangents. So both AB and AC are tangents because they touch the circle at one point. So AB touches at point B and AC touches at point C. Again, it intercepts 2 arcs. You have the outside arc, which is BDC, a big arc, and then you have the inside arc, which is just BC. So together, it's the entire arc, but to find that measure of angle A, just like the other ones, we're going to take the outside arc, BDC, we're going to subtract the inside arc, BC, and then we're going to divide by 2. So anytime the intersection is outside the circle, it's half the difference of the 2 intercepted arcs. So let's look at a few examples and then we'll be done. So first one we're looking for is the measure of KLM, right? KLM is this angle right there on the outside. So we have two secants, okay? We're looking for the two arcs that it intercepts. So the first one I do have a name for it, JN. That's the outside, that's the bigger one. And then the inside arc is KM. And we have both of those measures. So to find, and I'm just going to call the angle X just to make it easier. To find our angle, which I'm calling X, I'm going to take the outside arc, which is JN at 140 degrees. I'm going to subtract the inside arc, KM, which is 66 degrees. And then I'm going to divide by 2. And again, you can do this all at once or you can do it piece by piece. The good thing about using a TI-36X Pro or even Desmos is you can hit the fraction button and do it all at one time. 144 minus 66 is 74, and 74 divided by 2 is 37. So the measure of angle KLM is 37 degrees. Okay. On the next one, we're looking for the measure of arc MK. So we're looking for this inside arc right here. What we do have this time is we know the angle. So KLM is 56 degrees. We also know that outside arc KN is 160 degrees. So since I don't know the measure of arc MK, I'm going to call it X. And I'm going to solve. So to solve that, we take the outside arc, which is 160 degrees, KN. We subtract the inside arc, which is MK. I don't know it, so I'm calling it X. Divide by 2, and that should give us the angle, which we know is 56 degrees. So to solve this, since I can't do 160 minus X, I'm going to have to multiply both sides by 2. So that's going to give me 160 minus X, and 56 times 2 is 112. And then subtract 160. 112 minus 160 is negative 48, so that gives us negative X equals negative 48. We're going to divide both sides by negative 1, and that gives us X equals 48 degrees. So the measure of arc MK is 48 degrees. All right. Now we're looking for the measure of PQR. So that is this angle right here. I don't know what it is, so I would typically call it X. So I'm just going to kind of put it on the outside just because there's really not a whole lot of room right there. Let's look and figure out what two arcs it intercepts. All right, because the angle is outside, it always will intercept two arcs. So the first and the outside arc is going to be PS R. That's that big giant arc that we know is 313. Then I need to subtract that inner arc, PR. All right, well, they didn't give me the measure, but I do know that PSR and arc PR together make up the entire circle. So to find the measure of arc PR, I'm going to do 360 minus 313. Which is 47, so I can subtract 47. Divide by 2, and that should give us the angle, which we don't know, so I'm calling that X. So I'm going to do 313 minus 47, which is 266, and then I'm going to take 266 and divide by 2, which is going to give me 133 degrees for angle PQR. Again, anytime that angle falls outside the circle, it's going to intercept two arcs. Look at the arcs between the sides, subtract, and divide by 2. For the last example, we are not looking for a specific angle measure, we're looking for X. But X is part of the angle that is outside of the circle. So we need to figure out the measures of the two arcs it intercepts. So I'm just going to put letters here just to make it a little bit easier. We'll just call it ABC. All right, so the angle intercepts arc AB, which we do not have the measure of. and it also intercepts arc CB or BC, which we do know is 86. So we got to first figure out how to find the measure of arc AB. So we know the measure of arc AC is 74, even though it's not part of one of the arcs it intercepts. We also have BC is 86, and then AB is everything else. So if we add 74 and 86 together, that gives us 160. And then if we do 360 minus 160, that will give us the measure of arc AB, which would be 200 degrees. So now that we know that arc, now we can set up and we can find the value of x. So the angle, which is 4x plus 13, is going to equal the outside arc, which is 200, minus the inside, which is 86, divided by 2. So I'm going to do 200 minus 86, which is 114. I'm going to divide that by 2, so 57. So to solve this, we are going to subtract 13 from both sides. So it gives me 4x equals 44. Divide both sides by 4, and x is going to equal 11. So just as a recap, your intersections, when they're not central angles or when you don't have an inscribed angle, your intersections can happen 3 ways. The first way is they can intersect inside the circle. And if you have 2 chords or two secants that intersect inside the circle, you are going to find half the sum of the 2 intercepted arcs. So arc plus the other arc divided by 2. The next thing that can happen is you could have a secant or a chord intersect a tangent. And when that happens, the intersection will fall on the circle. When the intersection is on the circle, it is half of the intercepted arc. And then the third and final thing that can happen is that you can have an intersection that happens outside the circle. That could be 2 tangents, a secant and a tangent, or 2 secants. Regardless, if the intersection is outside the circle, you have to take the 2 intercepted arcs and subtract them. So the bigger arc minus the smaller arc, and then divide by 2. So it's half the difference of the 2 arcs. So inside is half the sum, on is half, outside is half the difference.